This video is going to serve as a quickie on how to take a 3D model and manipulate it in Autocad. This is specifically for the assignments where we have to take 3D objects and turn them into multi-view drawings, and I know this is a little bit difficult, so if you're a little bit challenged, don't despair. We can help you out. Now, normally in the CAD lab and in the drawing lab, we have little blocks of wood that you can actually pick up and look at from different orientations and different angles. And you get a better idea of the views. If you are not in the CAD lab or the drawing lab right now, though, you're at a disadvantage. So what we're going to do is we're going to ask you to download the model. And these models, you can stick them in your other folder of the B12 class. When the model's downloaded, simply go to AutoCAD and open it up. And when it comes in, it's going to look like this. Okay, so what can we do? How can we work with this? Well, first thing is if you hold down the wheel on your mouse, you'll see the little hand appear, and we know what that is. That's pan. And pan works in 3D just like it does in 2D. The other thing you can do is you can hold down the shift and the wheel on your mouse, and then what you'll see is we've got something here called 3D orbit. Okay, so with 3D orbit, what you're able to do is take the object and then spin it, rotate it into the different orientations, just like you would if you were in the classroom picking up this block and taking a look at it from the different angles. So it takes a little bit of practice to get used to the 3D orbit, okay, but it gives you an idea of what you're working with. And then thirdly, we would spin around to the side there and get a pretty clear view of the surfaces that we're working with as well as the edges we're working with. And you can probably see that I've color coded this. Yellow surfaces are front planes, cyan surfaces are top planes, the magenta surfaces are right side planes. And then for things with angles, I've tried to use a contrasting color for angles, and I've also used a contrasting color for curves, because curves obviously can exist in two planes at once. If I rounded off this corner, well, you'd see it from the front and from the side, so it's got its own color. Okay, and then what we're able to do is get an idea of what we're working with for the views. Now, when it comes to looking through the object, right, to figure out where is it hidden, where is it visible, you'll still have to do a little bit of visualizing to figure that out. Okay, but I think the 3D model gives you a pretty awesome advantage over just trying to guess. Okay, so here's our model 3.4. And here's 3.6, and like I said, angled faces, since they are typically viewed from two different views, have this dark blue color. Be aware of that. And then when there's curves involved, again, there'll be contrasting color to show you this is something that's seen from the top as well as from the side, or the front as well as the side. Now, there's one thing I need to point out that's very important about parts that have curves, okay, and that's that AutoCAD adds extra lines. Okay, the AutoCAD model displays some extra lines, and it happens right here where the tangential edge goes from curve to flat. Okay, so now look, if you were to look at this straight on, you might say, well, I'm going to draw the outline, all this stuff. I'm going to draw a line here too, and here too, because I see a line there in AutoCAD. Well, AutoCAD represents that curve starting at that point of tangency, but you do not. Okay? You do not. In technical drawing, you don't draw the line. This point right here does the same thing, right? Where it goes from flat surface to curve. It adds an edge, and an edge, well, I'm here to tell you those edges don't exist, so don't put them in your drawing. Same thing out here, right? Same thing here in the slot. It goes from curved, and that's the point of tangency, to flat. It adds an edge. So CAD systems add an edge to indicate flat to tangent, right? Flat to tangent arc. We don't when we do the technical drawing. So please don't add them. They are going to make your solution incorrect, and we lose points if we include them, okay? So nothing with curved tangent edges, please.